Hey everybody, and welcome to this video on multiplying and dividing real numbers. So let's make it happen. Alright, first things first, let's talk about how to write out multiplication. So for instance, 2 times 5. We got a couple of ways we can write this. The first way that we're used to is writing actually 2 and then a small x and then 5. So we've got 2 times 5. To be honest, we're actually not going to use this nearly as much as we may have in the past, especially because we're going to be using variables a lot. And our favorite variable to use is x. So this symbol right here could be mistaken for multiplication when it's really a variable, or it could be mistaken for a variable when it's really multiplication. Some other ways we can write it. We could also write 2 and then a small dot and then 5. And that also means 2 times 5. And a third way is we could write a 2 and then a 5 in parentheses right afterwards. And actually, you could put them both in parentheses if you want to. And to be quite frank, this is probably the way that we're going to write multiplication more often than not. Now note, if we were actually going to be multiplying a number by a variable, so for example, 6 times x, we don't even have to write any symbol. We could just write a 6 and then an x. And that implies that we're multiplying 6 by the variable x. So here are a few examples. 2 times 5, 3 times 4, and 6 times 7. Now, I'm sure that you already know that the product of 2 and 5 is 10, the product of 3 and 4 is 12, and that the product of 6 and 7 is 42. But I'd like to share one way that I like to think about multiplication by a positive number. So when you multiply an original number, we'll call it A, by a second number, we'll call it B, which is positive, such as in 2 times 5. It's as if that second number, 5 in this case, tells you how many times to add that first number to itself. Multiplication is actually just a way of condensing addition. 2 times 5 is the same thing as saying 2 plus 2 plus 2 plus 2 plus 2, which is of course 10. And 3 times 4 is the same thing as saying add 3 to itself 4 times. So 3 plus 3 plus 3 plus 3, which is 12. Or in our last example, 6 times 7 means add 6 to itself 7 times. 6 plus 6 plus 6 plus 6 plus 6 plus 6 plus 6, which is 42. Now, one theorem that's really helpful to remember with multiplication is the commutative property of multiplication, which says whenever you multiply two numbers together, you may switch the order in which you multiply them, and you will still arrive at the same product. That is, for any real numbers a and b, a times b equals b times a. So for instance, 2 times 5 is 10, and 5 times 2 is also 10. 3 times 4 is 12, and 4 times 3 is also 12. 6 times 7 is 42, and 7 times 6 is also 42. Now note, right now we're working with only positive numbers, but this is going to be true for every real number. What this also means is that whenever you multiply any amount of numbers together, you may rearrange them in whatever order you would like. For instance, 2 times 3 times 5 times 6. If I were to do this, I'd multiply the first two together and the second two together, and I'd end up with 6 times 30, and 6 times 30 is 180. And in theory, this should be the exact same regardless of whatever order we multiply those in. So for instance, 5 times 2 times 6 times 3. And if I were to do this multiplication and multiply the first two and the second two, we get 10 and 18, and 10 times 18 is 180. So again, whenever you're multiplying any amount of numbers together, you can multiply them in whatever order you'd like. Alright, before we go ahead and start multiplying by a bunch of negative numbers, let's start by discussing what happens when we multiply a number by -1. When we multiply a number by -1, you simply change the sign of that number. The number goes from positive to negative, or negative to positive. And you actually end up with that original number's additive inverse. So in this case, if we multiply 5 by -1, we'll get its additive inverse, namely -5. If we multiply a fraction or a decimal, it behaves in exactly the same way. 8/3 times -1 will give the additive inverse of 8/3, namely -8/3. And if we multiply -12 by -1, we'll get the additive inverse of -12, namely +12. With that in mind, now let's talk about multiplying by negative numbers. For example, negative 2 times 4, or 3 times negative 6. Now in one example, we've got a negative number being multiplied by a positive number. In the other one, we've got a positive number being multiplied by a negative number. So once we figure out how to handle these two, we should be good. All right, two ways to handle each of these. The way that I prefer is to think about it like this. Whenever you see a negative sign floating in front of a number, it's as if there's an invisible -1 being multiplied there. So in our first example, it's kind of like we have a -1 times 2. And in our second example, within those parentheses, it's kind of like we have a -1 times 6. And so what I like to do is immediately either rewrite or at least think about these problems as such. The first problem I think of as -1 times 2 times 4. And the second problem I think of as 3 times -1 times 6. And so now in each of these examples, we've got three numbers being multiplied by one another. And by the commutative property of multiplication, we can multiply them in whatever order we want. So in our first example, what I would do is multiply the 2 and the 4, and we get 8. So we have -1 times 8, which we know is -8. In our second example, I'd actually prefer to multiply the 3 and the 6 first to get 18. So I'd actually rearrange the problem first. You don't actually have to write it out again, but I like to just to be very explicit. And now we can multiply the 3 and the 6, we get 18, and -1 times 18 is -18. Now that's the way I prefer to think about it when we're multiplying one positive number and one negative number, regardless of the direction. If you want, you can go back to our original way of thinking about multiplication as a way of condensing addition. Right? If we're multiplying something by a positive number, that positive number says how many times should you add the other number to itself. So for example, in -2 times 4, this means add -2 to itself 4 times. And we get, of course, -8. In our second example, 3 times -6, it's a little bit odd here because I'm not sure what it means to add a number to itself -6 times. But we can rewrite 3 times -6 as -6 times 3 by the commutative property of multiplication. And we know exactly what that means. It means add -6 to itself 3 times, which of course will yield -18. And perhaps you've already noticed this, but in general, whenever we multiply two numbers together, one of which is negative and one of which is positive, the product is always going to be negative. Now this strategy of adding these numbers to themselves a certain number of times is going to break down when we multiply a negative number by another negative number. So this first strategy we discussed is the one I prefer and the one that we're about to use. Alright, so what happens when we multiply a negative number by a negative number? Well, the strategy I like to employ is this. Again, every time you see a negative number, you can think of it as -1 times a positive number. So -4 we can think of as -1 times 4. -9 as -1 times 9. -6 as -1 times 6. And -3 as -1 times 3. So what I would do for our first example is either write it out as, or at least think of this as, -1 times 4 times -1 times 9. At this point, we can multiply these in whatever order we'd like. So I'm going to rearrange it so we've got all our -1s to begin and all of our not -1s at the end. And now, if we multiply the first two together, -1 times -1 is 1. If we multiply the second two together, 4 times 9 is 36. 1 times 36 is 36, and we've got our product. Similarly, for our second example, I would write this out as, or at least think of this as, -1 times 6 times -1 times 3. Again, we can multiply these in whatever order we'd like. Let's go ahead and put all of our -1s in the front and all of our not -1s towards the end. Of course, -1 times -1 is 1. 6 times 3 is 18. 1 times 18 is 18, and we've got our product. And in general, whenever we multiply two numbers together, both of which are negative, the product is always going to be positive. Alright, a couple properties of multiplication that are going to be really helpful for us. The first one is, whenever you multiply a number by 1, you end up with that number itself. That is, for any real number a times 1 equals a. So 5 times 1 equals 5, -2 times 1 equals -2, etc., etc. What about multiplying by 0? Whenever you multiply a number by 0, you end up with 0. That is, for any real number a times 0 is 0. So 5 times 0 is 0, negative 2 times 0 is 0, anything times 0 is 0. Alright, here's another one that's going to be really, really important for us. For any non-zero real number, we'll call it a, there is another real number, which we'll call b, such that when you multiply the two together, in either order, remember, commutative property of multiplication, the product is 1. These two numbers, a and b, if you multiply them together and get 1, they're called multiplicative inverses, or reciprocals of one another. Consider 5, 12, and negative 8. My claim is that for each of these numbers, there is another number we can multiply by it to get 1. So for 5, what could we multiply 5 by to get 1? I think 1/5. 5 times 1/5 is definitely going to be equal to 1. That means that 5 and 1/5 are multiplicative inverses of one another, or reciprocals of one another. Same thing with 12. 12 times 1/12 will give us 1. 12 and 1/12 are multiplicative inverses of one another. And negative 8. If we multiply negative 8 by 1 over negative 8, or you could call this negative 1/8, we end up with 1. So negative 8 and negative 1/8 are reciprocals of one another, multiplicative inverses of one another. So we see that we're ever working with an integer, in order to find its multiplicative inverse, or reciprocal, all we need to do is take 1 over that integer. The multiplicative inverse of 5 was 1 over 5. The multiplicative inverse of 12 was 1 over 12. The multiplicative inverse of negative 8 was 1 over negative 8. But what about fractions? How do we find the multiplicative inverse of a fraction? For instance, 2/3 or negative 7/4. Let's start with 2/3. So we're going to have to multiply 2/3 by something so that we end up with a fraction in which the numerator and denominator are exactly the same. Because if the numerator and denominator are exactly the same, we'll end up with 1. So let's think. Well, if I multiply 2 by 3 and multiply 3 by 2, well then we'll end up with 6 over 6. And 6 over 6 is the same thing as 1. So the multiplicative inverse of 2/3 is 3/2. Interestingly, all we needed to do was switch the numerator and denominator to find that reciprocal. What about negative 7/4? Again, we're going to have to multiply by something so that we end up with a fraction in which the numerator and denominator are the same so that it's equal to 1. Okay, well, first things first. If we need to multiply negative 7/4 by something to get positive 1, we need to multiply it by some negative number. So we know that fraction is going to be negative. Similarly to the last example, if we multiply 7 by 4 and multiply 4 by 7, we'll end up with a fraction 28 over 28. Of course, it's going to be positive because we've got a negative times a negative, so that'll be positive, and that's equal to 1. So the reciprocal of negative 7/4 is negative 4/7. Again, we just switch the numerator and denominator. And in general, if you're ever trying to find the reciprocal or multiplicative inverse of a fraction, all you got to do is switch the numerator and denominator. All right, now let's talk about division. And first, how to write division. Suppose we wanted to write 24 divided by 8. The way we would write that is using a fraction. We would write this as 24 over 8, which means 24 divided by 8. A big note, we will almost never, ever, ever use this symbol to represent division. It's a little bit cumbersome, and we are rarely ever going to use it. Almost all of the time, we're going to use a fraction to represent division. So in this case, 24 divided by 8, 24 over 8, that's 3, because 24 divided by 8 is 3. Or for instance, negative 42 over 6 means negative 42 divided by 6. 42 divided by 6 we know is 7, and so we have negative 7. But there is something I want to point out about what just happened when we divided. And using a fraction to write division is really going to help us make this connection. My claim is that 24 divided by 8, or 24 over 8, is the exact same thing as 24 times 1/8. Or similarly, negative 42 divided by 6, or negative 42 over 6, is the exact same thing as negative 42 times 1/6. In our first example, dividing by 8 was the exact same thing as multiplying by its reciprocal 1/8. Or, for negative 42 over 6, dividing by 6 was the exact same thing as multiplying by its reciprocal 1/6. And this is actually going to be true all of the time. In general, dividing by a number is the exact same thing as multiplying by that number's reciprocal, or multiplicative inverse. And this is going to be really helpful anytime we see some trickier division problems, such as the 3 at the bottom here. So in our first example, 6 divided by 3/2. That's a little bit tough, but as long as we know that dividing by 3/2 is the same as multiplying by its reciprocal 2/3, then life will be a lot easier and we find our product to be 4. In our second example, this is another awkward kind of problem. 5/8 divided by 15. Well, all we need to do is recognize that this is the exact same as saying 5/8 multiplied by 1/15. Or in our last example, 2/3 divided by 7/4. All we need to do is recognize that this is the exact same thing as 2/3 times 4/7. But note, one other thing to keep in mind is that whenever we divide any number by 0, the quotient is undefined. 5 divided by 0, it's undefined. Negative 3 divided by 0, undefined. 0 divided by 0, undefined. Whenever we divide anything by 0, we don't get 0, we don't get infinity, we don't get anything else. Our quotient is undefined. All right, time for some practice problems. In front of us, we've got 10 multiplication and division problems involving positive and negative numbers. So why don't you pause the video, take care of these 10, and when you're done, play the video, and we'll see how it went. All right, just a few more practice problems. So let's go ahead and use all these properties we just discussed with a couple of expressions. These are going to involve some variables, and we'll need to recall the order of operations when we carry them out, but they're going to be really helpful for us moving forward. So let's think of our first one. Negative 2 times the quantity of m minus 7. Now, we don't know what number m is, but we know that m represents some number, and so m minus 7 is some number. Well, how do we multiply negative 2 by this unknown number since we don't know what m is? Well, we can use the distributive property, which says that for any quantities a, b, and c, a times the quantity of b plus c, well, we just multiply a by b and also a times c. So we end up with a times b plus a times c. Or if within our parentheses we have subtraction, so b minus c, again, we're going to multiply our a by b and our a by c, but we'll be subtracting. So we get a times b minus a times c. And in this case, we're going to do exactly that. We're going to multiply this negative 2 by both m and by negative 7. And we end up with negative 2m plus 14. So whatever number m represents, we don't know which one it is, whatever number it does, negative 2 times the quantity of m minus 7 will equal negative 2m plus 14. All right, let's take a look at 8 plus 2 times the quantity of h minus 5. Now, first things first, order of operation says we need to do multiplication before addition. So what we're going to do is we're going to multiply this 2 by the quantity of h minus 5 before we add whatever that is to 8. So we're going to use the distributive property again. We'll multiply 2 by h and 2 by negative 5. So we end up with 8 plus, well, 2h, and then 2 times negative 5 is negative 10. So we end up with, well, the 8 and the negative 10 we can combine. 8 minus 10 is negative 2. So we end up with negative 2 plus 2h. We can't combine the negative 2 and the 2h because we don't know what h is. So we don't actually know what number 2h is. So that's all we can do. All right, our next example is a little bit tricky. Why? Because we're going to be multiplying negative 3 by all of these negatives in parentheses, and we got to be really sure that we're really on top of our signs. So one thing I might do to make our lives a little easier is rewrite this statement as 16 plus negative 3 times the quantity of negative 2x minus 5. And from here, I think it's a little bit more clear what we need to do. We need to first do multiplication, and we need to multiply negative 3 by negative 2x and negative 3 by negative 5. And whatever we end up with, then we'll add 16 to that. So we end up with 16 plus, well, negative 3 times negative 2x will be positive 6x, and negative 3 times negative 5 is 15. We can combine the 16 and the 15. 16 plus 15 is 31. But we can't combine that with the 6x because we don't know what number 6x is, because we don't know what number x is. So this is all we can do, and we leave it as 31 plus 6x. So why don't you now take a crack at this third expression and simply rewrite it having done that multiplication. Alright guys, that's it for this video. I hope you found it helpful, and I hope you enjoyed.